Slopes of parallel lines. So when we talk about the slopes of parallel lines have the same slope, which makes total sense. If two lines have a rise and a run that are the same, they're going to be parallel and they're never going to touch each other. So let's take a look at how we see that when we look at equations of lines and slopes of lines. So we're going to look at this figure here, and we're going to try to decide if AB, side AB of this figure, and side CD of this figure are actually parallel. When we get into geometry, we never want to assume. This looks like they're parallel. It looks like a rectangle, like we have parallel and right angles in our corners. We never assume with geometry. We always want to either be told it explicitly or prove it through what we know. So let's take a look at lines AB and CD. So line AB has 2 points in it, A and B. I'm going to take those ordered pairs and find the slope of the line that goes through those points. In this case, I end up with a slope of 3/8. I'm going to take line CD. I'm going to take the 2 points that I know are on CD that have been given to me. I'm going to find the slope through those 2 points also. And I end up with a slope of 3/8 also. So I know that these two lines are parallel because I've proven that their slopes are the same. So line AB is parallel to line AC because they have the same slopes. So when I have two lines, I've proven that they have the same slope. I know that those lines are parallel to each other. What can we do with that? So let's say write an equation in slope-intercept form for the line that passes through 4, -2 and is parallel to the graph of y equals 1/2 x minus 7. So when I have two parallel lines, they'll have the same slope. They will not have the same y-intercept. That doesn't make any sense for them to be parallel and pass through the same point. So when I look at this equation here, I have y equals 1/2 x minus 7. I can pull some pieces of information about it. Some of the pieces of information about that line are also true about my new line, my new parallel line, but not all of them. So I can take the slope out of there. The original slope is 1/2. The original y-intercept is -7, but that's not going to be the y-intercept of my new parallel line. It has to go through a different point on the y-axis. So the only piece of information that's really important to me about my original line is the slope. Slope of the original line is 1/2. Since I know the slope of the original line has to be parallel to the slope of my new line, my parallel line here, I'm going to use the same slope. But everything else, I'm going to wipe it clean. So the only thing I know right now about my new line is that it has a slope of 1/2. They also tell me that it has to go through this point. So they've given me a point on that new line of 4, -2. So I'm going to use that. I'm going to forget all about the original line. None of it applies anymore. Forget it. I'm going to move on to this new line. It has a slope of 1/2, and it goes through 4, -2. So now I'm starting from write an equation of a line that has a slope of 1/2 and goes through point 4, -2. So I've got my slope-intercept form. I could use point-slope form too. They want it in slope-intercept form when I'm done, so it makes sense to start there. I'm going to plug in the ordered pair that I know goes through that line. I'm going to do my algebra, and I come up with a new y-intercept for this new line of -4. So my equation for this parallel line is y equals 1/2 x minus 4. Notice the only thing that these two have in common is their slope. Their slope is the same. Their y-intercept is not the same. If they were the same, it would be the same line. So they have to have different y-intercepts.